Now I want to discuss with you the graphs of the trigonometric functions. As you know, nowadays we find maximum number of informations represented either in the histogram or in the bar graph or in the form of frequency polygon, ogives, even in the market trend. What we see in the evening news, we see the G business or we see any of the news channel, we always find either it is the crime rate or something or some percentage. People always represents the informations, the data in the form of some pictures to make it very informative, to make it interesting, to make it something very fruitful. Same way here, even in class 10th, you all know how to plot the graph of the linear equations 3x plus 2y equals to 7. What are their results? If two graph lines intersect, they are having one common solution. Two lines are parallel, they do not have any solution in common, no solution. If two lines coincident, they have infinite number of solutions in common. By this way, we know that graphs are possible, useful, required, and lot many things are to be delivered after plotting the graph. So now I want to tell you how to represent the graphs of the trigonometric functions and what are the various outcomes if the graphs are drawn. First of all, I want to tell you the graph of sin x. If I say y equal to sin x is the first primary basic trigonometric ratio. Now, few things I would like to tell you before I go to put its graph to represent the graph. We know that the sine function, it is given by, in class 10th you know sin theta is given by perpendicular upon hypotenuse. So this is the reason that the value of the sine can never be more than 1. Why? You know it very well that perpendicular is always less than the hypotenuse. If I divide both sides by hypotenuse, I will say P upon H is the sine theta or sine x. Hypotenuse upon hypotenuse is 1. Sometime you may be asked, what is the reason the value of the sine function is always less than or equal to 1? As it can never be more than the hypotenuse, that's why the value of sine can never be more than 1. In the previous lesson, I told you in the chapter trigonometric functions, as and when we move in the quadrants, the values of the trigonometric function sine gets changed. In first and second quadrant, the value of the sine function is positive. Third and fourth quadrant, the value of the sine function is negative. So I can assure you, you just can make a learn that the value of the sine function is always less than equal to 1 and more than equal to minus 1. So value of the sine is always lies between minus 1 and plus 1. The reason for this, as explained you, the value of the sine is given by perpendicular upon hypotenuse. In any triangle, in any case, the perpendicular can never be more than hypotenuse. That's why this division can never give the result more than 1. In the extreme condition of the 90 degree, perpendicular and hypotenuse may coincide. So in that situation, the value of sine may be 1. Now, perpendicular is less than 1, dividing both sides by hypotenuse, sine x is always less than 1. But in case of the x90, perpendicular and hypotenuse coincides having equal length. That's why this value become 1. But as and when we move in the quadrant, as explained to you, the value of the sine x may lie between minus 1 and plus 1. This is the first reason that the range of the sine is minus 1 to plus 1. Now the concept come, what is the domain. What is the domain of the sine function? If I explain you, there is no value of x at which the value of sine x cannot be defined. Sine x defined on every value of x. So I can say it is y is equals to sine x. Its domain. Domain means set of all such values of x on which the sine x gives some value. Domain x belonging to real number. Domain is x belonging to real number. Y is equals to sine x. It means that at any angle, maybe 0, maybe negative, maybe positive, maybe infinity, maybe any angle, the value of sine is always defined. It never comes not defined. It never comes undefined. It never comes indeterminate form. That's why the domain of the sine function is x belonging to real number, and the range of the sine function is from -1 to +1. Its reason is previously explained you. Now after getting what is the domain, what is the range, I want to tell you what is its principal domain. That I will explain you while I will draw the graph of the sine function. Now I would like to explain you that how to draw the graph of the sine function. To draw the graph of sine x, we have to take two axes. One the horizontal one as usual x axis, vertical one is the y axis. X axis and y axis where they meet, point of intersection is known as origin, that is 0, 0. Now the question raised that if it is origin 0, 0, if I take, suppose I am putting 0, 0 here, 0, 0, if this angle is pi by 2, that is 90 degree, this is 180, that is pi, this is 3 pi by 2, I am taking the intervals of 90, 90, then it is I am taking 2 pi, this is I am writing here x axis, this is y axis, suppose this is 1, this is 2, -1, -2, this is suppose negative direction minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. This on the graph paper you can do, and sine 90 you know 1. So the graph of the sine function comes like this: sine pi 0, sine 3 pi by 2 270, minus 1, sine 360 is what? 0. This is -1, minus pi, -1, like this, +1 and then. So the graph of the sine function is coming in the shape of this curve. Question raised, why I have not joined the points of the 0 and pi by 2 by the straight line? Why I have not taken the graph of the sine function like this? The reason is, if I join it by 0 and 1, that is pi by 2, with the help of a straight line, then the all angles between 0 and pi will not fall on this straight line. They always fall on a curve. So the graph of the sine function is taken as the curve. Its amplitude or the range is from -1 to 1, because the least value where the graph can go is -1 and highest point, peak point, is +1. So the domain of this function is any real number. Domain is any real number. The range is from -1 to 1, and PD, I am using the short form, principal domain. Remember, very important term. The principal domain of the sine function is from -pi by 2 to +pi by 2 in the language of radians, but if you will convert in degrees, it is -90 degree to +90 degree. So ultimately what is coming, that the domain of the sine function, is any real value because it is defined on any angle, every angle. This is the first reason. Range is from -1 to +1. The reason is very simple, because the value of the sine can never go less than -1 and can never go more than +1. Domain